Engineering Eng. PDF document of this video is on engineering.com.
Friends, I hope you are well. In this video, we explained how to convert coordinate system to each other in one of the videos we explained earlier, but we did not solve an example. I wanted to solve a few examples about them in this video for you. Now I wrote 4 examples in the first of these. When we look at it, you see that converting ex plus ey to cylindrical coordinates, e rho plus e theta to Cartesian coordinates, a multiple of 2 phi multiplied by a factor of 3 r e theta. Here we call any variable is something like 3 or 5. Both be familiar with the variables, and I have added a few things. You can see this way. For example, 3e theta may be I2e phi, but here phi is magnitude. We are not detected from the elements of coordinate systems, and we have written something again. Here again, he wants used to turn it into a cylinder, a Cartesian and a sphere. We will try to do them. As I said, if you watch our transition video between coordinate systems and in one of the previous video, there are some terms we have obtained there. Now let's start with the solution for example 1 if you want. I rewrite the example 1 like this. Here it says convert ex plus ey to cylindrical coordinates. If you want, so with black color. Now I have to use the transition regarding cylindrical coordinates. Which transition will I use for this? You see here, he wants used to convert ex and ey to e rho, e phi, ez. That is to say the cylindrical coordinates. Now, to decide whether we are going to use the transposition or the non-transpose form from here, I have to do this. I have to look at what I have. When we look back again, what I see, I have ex, ey. So when deciding which one to use, what I have is this part, and I will use the transposition. Okay, so what do I mean here? So I'm going to get ex from here. What is the equivalent of ex? What is this row times this column? I'm writing it here instead of ex, guys. So for ex, I say that what I found ex is equal to what? Cos phi e rho minus sin phi e phi. Also, what do you see when you look at it like this? If cosine phi times e rho minus sin phi times e phi times 0, then this means that it equals what it is, e equals x. Now I need ey, right? When I looked, I wrote ex and now I write ey. How do I write e again under the same figure? Ey equals sin phi times e rho primary times primary is plus cosine phi times e phi 0 times ez, right? Let's write again. Now, so the sine is with rho, the cosine with phi. Then what I am writing from here is that y equals sin phi e rho plus cosine is equal to e phi. At that time he was asking me what y, friends, are the sum of these two, because I need this, I am looking for this. Which type I am looking for? Look, what comes from here? The left side is equal to this, as ex plus ey is equal to this side. Cosine phi plus sin phi in brackets e rho plus, let's write the rest on the bottom. The rest are cosine phi minus sin phi and e phi. Okay, guys. As you can see, guys, We have Ex and Ey in the Cartesian system. We have converted to cylindrical coordinates in this way. When we look here, we did not leave anything with phi, and there is x, y, and that was the purpose. This was the first example. Now we are looking at our second example. In example 2 also tells me that e rho plus e theta time, this time it says convert in Cartesian. See, it will be an interesting example. We'll see more clearly why this is so later. Example 2 has asked me what is an expression with e rho plus e theta. Okay, you know that the trouble here tells me to convert to x, y, z. Then when you look at e rho plus e theta, and the interesting part is that rho is the element of the cylinder and cylindrical coordinates, and theta is the element of the spherical. Then what should I try to reach? I will write both the x, y, z type and the theta separately. Which ones do I need to look for to use this? You know that before the transitions here, let's consider e rho because e rho is cylindrical. We'll look at the cylindrical transition as we just looked. When we look at the cylindrical transitions again, what do I see? I have e rho and I know that its x, y, z transition is again cosine phi times ex, sine phi times ey, 0 times ez. I write the equation by pulling from here. This time, you notice that cosine phi times the non-transposed part. I got cosine phi times x sine phi times ey this way. We can do it, okay? Now, after I wrote this, what kind did it have on my hand? I have found this equation in terms of ex and ey. Now let's come to the equivalent of e theta. Where do we see the equation of the theta, guys? I have to look at the transition of spherical coordinates because this is the only way I can find e theta equals ex and ey. Now when we take a look at it, what do I need? Is it one of them or the equivalent of theta? Of course, I need this. What do I have to define it? Since this is the second line, you multiply the second line with the whole. You know, we multiply them exactly. Cosine theta sine phi ey. Cosine theta cos phi ex plus, what was it? Using this table, cosine theta sine phi e y. Okay, let's see if something has to do with 0 over z. Unfinished, right? It includes minus sine theta times ez. Minus sine theta times ez is come. Now we want to the sum of these two form me. In the same way, we will do the collection to the party since e rho plus e theta is equal to cosine phi plus cosine theta. I can write cosine phi in parentheses 1 plus cosine theta times ex. Ex, right? E with y, what is there? Sine phi cos theta, then I can write like this plus, I say 1 plus cosine theta ey in this sine phi parentheses. Ez is just minus sine theta ez. That's it. Okay. This is our solution. You write the answer for example 2 like this. When you look here, it is just ex, ey, ez. Now you can say that there are phi, there are theta. What are these? After all, in that coordinate plane, the theta here are now coming as magnitude and the direction is no longer a vector. This is what we need to focus on. Okay, we will understand better what I mean here with some later examples. For example, in example 3, when we look at example 3, I wrote something with r. Look, the same thing is that r being here is phi. The important thing is that there is no direction vector. For example, here is the absence of e phi or e rho or the direction vector of any cylindrical or spherical coordinate element. When we look at it here, they are real elements of direction vector ex, ey, ez. That is the Cartesian coordinate system. On the other hand, let's take a look at how to do it when we take a look at example 3. Next is example 3. Example 3, I wrote it like this again. In example 3, what asked me when we look at 3 r e theta plus 2 phi er. Now friends, it's asking me to roll it up here this time. Let's have a look. I think this example 3 may take some time because there's a spherical here and I have a transition from spherical to Cartesian, and then it wants us to turn into a cylinder after passing to Cartesian. Looks like it will tire us little. Let's start solving it if you wish. Let's look at who is being asked to translate things I needed before. Note that the rotation vectors are asked to be converted into cylinder. We'll make them cylindrical. Here I have to write e theta first. E theta, first of all, you have to take the transition form from your Cartesian to the Cartesian. We have just written the equivalent of e theta. We write before cos theta cos phi ex cos theta sin phi ey minus sin theta ez. Something quite long is going to happen. If you wish, let's write this first. We wrote it somewhere above. We can probably write from there. Likewise, imagine that we wrote exactly what is written above. Cosine theta cos phi ex cos theta sin phi ey minus sin theta and ez. I prepared it a little difficult. Frankly, I admit it was long, guys. Also because I said third or something unnecessarily after them, but there's nothing to do. We'll try a little. Okay, what I need after e theta is er. We write the er as follows. I need to get the equal of er again from our second sign spherical transitions. Er, what was sin theta cos phi sin theta sin phi cos theta? Let's see that sin theta must be cos phi ex sin theta sin phi ey plus cos theta ez. Let's see if it is true. Let's start sin theta cos phi sin theta sin phi cos theta. Yes, it's true. We wrote it this way, but one of the interesting points is this. This time here it asks me to switch to cylindrical coordinates. That's the point. I am expected to write this without feeling lame. Of course, you will multiply each term by 3r, and you will multiply each term by a coefficient such as 2 phi. Such coefficient numbers will come here. The following ex after that will be ex multiplied by 3r cos theta and cos phi in the bracket, who is next to ex. In the same way, there will be 2 phi at the beginning of EX. 2 phi sine theta cos phi plus. Notice that. Who will be the terms with EY? If you want, let me show that I wrote by adding after multiplying. I multiplied it and added it. If we say result here, if we say R for short, I find R right now, then let's focus on who has Y with Y. When we look at it, the EY is 3R cos theta sine phi 2 phi plus 2 phi sine theta sine phi. So finally, who is there plus EZ? In the E brackets, you find it cos theta minus sine theta. The process is not over. Okay, he asked me to turn it into a cylinder. But I won't touch the Z because there is Z in the cylinder. I don't need to touch that part. In this section, I have to find the equal of EX and EY. This time, I find the equal of EX from transposes. This is the equal part. EX is equal to cos phi E rho minus sine phi E phi. Cos phi E rho minus sine phi E phi. That's right. What was that? Cos phi E rho minus sine phi E phi. You bring in EX and write this term here as it is. Let's take a look at it again. EY equals sine theta E rho cos phi E phi sine phi E rho cos I E phi. Sine phi E rho cos phi E phi equals EY, right? If you arrange it, you have to say, you will imagine that I bring this and replace EX here as it is, and when we put this here, the process ends, my friends. I will not put them, you will, my friend. As I said, when we put these terms in place of EX, a term with E rho and E phi, and we will put this in place of EY, a term with E rho and EF will come. In other words, there is EZ here. I will automatically translate it, and we will express it in terms of cylindrical coordinates with rho phi z, which it wants from me if you put the following in place in the wall and the wall. Let's come to our last example. Let's see what he asked in example 4. What does 2 rho E rho plus EY equal in terms of systems of spherical coordinates? Let's take a look at this if you want. 2 rho E rho plus EY. Let's write example 4 and I will deal with it. It is 2 rho E rho plus EY. Is it true? 2 rho E rho plus EY, yes, true. Who wants to us translate it to now? He wants to convert it to spherical. What was spherical? R was theta, and the one in phi. So when I take a look here, what should I focus on? First of all, I cannot direct the transition of E rho, which is a spherical coordinate system element, to spherical coordinates. So first of all, I will turn E rho into a Cartesian. After turning into Cartesian, we will look again. To convert it to Cartesian, let's look again at the equal of the what ER in Cartesian terms, that is E in terms of x. Since I am looking for its equivalent in Cartesian terms, I will focus here. I am looking for this and focusing here. I get cos phi x plus sin phi ey plus 0 for cos phi x sin phi y. Let's bring it and write it here if you want. I put a comma here and I write the equal of E rho. Its equivalent was cos phi ex plus sin phi ey, if I'm not mistaken. Well, I wrote it this way and look what I have. What does he want from me? Now let's first say this ey, but it also says that after multiplying by 2 rho, it says sum. So after all these terms have been multiplied by 2 rho. Anyway, you bring the equals ey and add these two. Then I get this on the left side and it's also with those 2 rho. And after all terms are multiplied, when I add these two, what I'm looking for is that r equals r. Then r equals from that side. I find 2 rho to E rho plus EY. How did I find E cos phi EX I in X? If E is in terms of Y, what did you see when I added up? I made a mistake. See here, I said what said we multiplied by 2 rho, but I forget to multiply here. Let's write without forgetting. 2 rho cos phi ex plus, this time I go to ey's, but notice there is a term here with ey and there is a coefficient ey here. Then I can write them in brackets 1 by y like this. I open the parentheses 2 rho sin phi plus 1 times ey. There are 2 rho sin phi ey coefficients plus 1 coefficient. Here I got 1 ey in the middle bracket. As what does he want from me here? He was asking me to translate spherical coordinates with ex and ey. So I will go to spherical coordinates. I have ex and ey in spherical coordinates. This ex and ey must be equal in terms of sphericals. So since I need the equivalent of ex and ey in terms of the spherical coordinate system, I bring it to me and write it like this first. First I write ex equal to sin theta cos phi er cos theta cos phi e theta minus sin theta e phi. Frankly, it was quite tall, right? Let's rewrite it like this: sin theta cos phi and I write here ex first, sin theta cos phi er cos theta cos phi e theta. E theta, right? And finally, let's write who was there, minus sin phi e phi. Finally, who shall we write, my friends? As you can see, this ex we have now expressed in who. All of them are now in terms of spherical coordinate systems. If you bring it and write this instead of ex here, if you bring the whole equation and write it here, I will automatically turn the left side into a spherical coordinate system. I also have to write EY. Let's rewrite the EY so that you can understand both the reading and the logic of these matrices and why we use of them. Finally, let's write the equation of EY. Let's keep our minds from the chance this times in the equal of instead of sine theta cos phi. As I said, if you write this here, it will finish our process. Here, the only difference that change from the upper one is the cosine sine plus cos is phi. I said cosines would be sine, but which cosines? Okay, it should look like this. It should be sine theta sine phi er, cosine theta sine phi e phi plus cosine phi e phi. Making a review, yeah. Yes, friends, as I have made, you will get the term with y. You see here from the here, and if you write it here, we will express it in terms of EY. So the spherical coordinate system, we change it, okay? So I will have translate the spherical coordinates in terms of system. Of course, I saw the here without forgetting. You don't have to, but you can turn into each other. This size is now the size you want, but if it is 3, the product of this 3 is different. For example, the product of this is 3, but this is the way it's, for example, here is 6, here is 60. You multiply 6 by 60, you get 3. We know that rho cos phi equal to phi x anyway, so we have already translated ex, and I am just writing the expression for the ratio. There's an expression that 2x ex. What I just mean here is that I mean by 6 by 3, if x is 3, then rho cos phi is such a product that the product of something and something equals 3, because I could write x instead. We know this from rho cos phi's x theory. I say this, it's as a possibility. There is no rule that will be like this. It may be another value, but I'm saying in terms of availability. For example, here the length rho becomes 6 if the angle of cosine phi is 60 degrees. Cosine phi becomes 1/2. When you hit rho 6, it gives 3 again. So rho cos may be equal to phi x. You can think of logic like this. As I said, I think you understand well. In these 4 examples, how are they translated into each other? What is the logic? Because in some example, this translation is very useful for the business and we use it. In order to reinforce this, I felt the need to explain this video. Thanks for listening. See you in other video.